Okay, now recursion.
Yeah, so yeah, you're presenting now.
Yes, I'm presenting.
So now we'll start with recursion. Recursion is a very big topic.
Hmm.
So we'll use stacks. So basically stacks में कैसा जाता है वैसे हमको समझना पड़ेगा. So what is recursion?
Yes.
It's a programming pattern where you solve something bigger problem by solving smaller instances. This will be very useful for remembering how dynamic programming works.
Hmm.
Dynamic programming में if we use recursion, the stack depth के लिए हमको issue होगा.
Yeah.
So you either use storage, you store it what you say at one place, which will be the iterative way to do DP problems, or you
Hmm.
just you just recursively call the same function by inside it.
Memorize.
Yeah, same
Memorize.
function. Yeah, which is called the memoized version. No, which is what? Wait, memoized, recursive, tabulated. No, three types of approaches.
Yeah.
So yeah, now we are going to discuss recursive only. Afterwards, if we get some time, some other time, then we can do for that dynamic programming, the other topics. What is this factorial and yeah, the two important problems when we are discussing recursion, factorial
Hmm.
and Fibonacci.
Hmm.
Hmm.
If n equal to zero, base case we need the logic
So we
and
need logic. So first thing we have to remember is we have to first do logic, how to do recursion.
hmm.
So what is factorial? It's nothing but n into n minus 1 into n minus 2. So we can directly do n into fact of n minus 1, which will take care of the stack depth. So if we
Hmm.
leave like that only, it will lead to infinite loop, I guess. It will go to negative numbers also. So at some
Yeah. So
point we
that's
have
why
to
we are
stop.
using.
That's why then we have to think about base case.
Hmm.
So that is what factorial. Easy only it is.
Hmm.
Yeah. So then what can we
Next.
do? What into sum? In plus it's sum of n minus 1. What are we doing there? Sum of n
This
numbers,
is
huh?
hmm.
Okay, that is sum of n numbers. Fine, I got it.
In natural numbers.
This is Fibonacci. Fibonacci is for Fibonacci we have to remember fib of n minus 1 and fib of n minus 2. Then base case is 2. Two things we have to remember. Yeah, this all dynamic programming may it will be much more important. You go down. Now we do not need to remember all
Hmm.
this. AP sum is what? Okay, that also we understood of.
Same.
Yeah, okay, yeah.
Same.
Yeah, you can go down. You can still go down.
This.
You can go down a lot. You can go down Tower of Hanoi. What is Tower of Hanoi? Yeah, this we I remember. अरे एक बार बताओ रे.
Tower of
Intro.
Hana is nothing but be given three rods, and in these three rods we'll given some n number of discs.
Hmm.
In these discs, it should be smallest one should be on top and the biggest one should be on the bottom.
Hmm.
We should shift these discs to the C tower
Hmm.
using the B tower. And
Hmm.
the rule is that the smaller one cannot be kept below the big one.
Hmm.
That is the condition. So, what we'll do is first we'll shift from A to B, then B to C. Here we want to go from A to C, no?
Hmm.
So our first logic we'll shift as many disk we can keep from B A to B, and
Hmm.
then after going to B, then we can shift it to C. So we'll use from A to B here.
Hmm.
Prompts it to using C. So using C, first we'll keep in C, uh, then we can keep C to B, then A to C, C to B like that. So
So
it
basically, what we are doing is we are shifting n minus 1 disks to what is a B. So that
B.
so the biggest disk will be left on A, so we can shift that directly to C.
Hmm.
That's only no. Then we can
Yeah.
then we'll write the print statement moving what you say
Moving
the
this one from uh, the rod A,
to
tower A,
tower
to
C
tower
towers
tower not
towers
C, tower B.
tower. No, we are moving from A to C, I guess. No,
No, C.
no, I
From
no see because A to B using C, then B to C using A. So we are moving everything to C.
A to B using C. First C. From A
Uh,
to B
uh,
using C. Here what it is, what you're telling. From B to C using A.
wait. ఒక్క నిమిషం ఆగు. If n is equal to 0, system dot out println move from 2 to 2. Okay. From 2 to. What is happening here? So first what is happening is A to B using C we are doing.
Hmm.
Okay, so A to B using C, somehow what is say everything went off, n minus 1 disks went off somehow. We are thinking.
Ah, yeah.
Okay, now one disk is left at A.
Hmm.
So all other disks are at B, no.
B.
All other
B or
disks
yeah, B only.
all other disks are at B. So
Hmm.
again we are moving the largest one from A to B.
No, we'll move it to A to C, no.
Okay, we'll move largest disk. That's only I'm telling. We move largest disk to C, no.
Yes.
Yeah. Then what we'll do? We'll do all the disks from B to C using A.
Hmm.
Yeah, that only I'm saying. So we are at the last all the disks will be stacked at C.
Ah, here last mate will be at start at C.
Okay. Some weird logic this has. So
Hmm.
that we have to remember. We just have to know that we have to move from A to B, A to C. Somehow we have to move and we have to
Hmm.
print. Okay, do some bullshit. So if you just remember the logic, that's enough. Go down.
Hmm. Hmm.
Uh,
This one same A power and again same thing became
yeah, A power n is same as A power b now. So this is recursive solution.
recursive solution.
Okay, this recursive solution is much more easier to remember for me.
Hmm.
Yeah. Okay, leave off.
Then this time complexity of that uh, sorting.
Sorting. Sorting में मेरे को एक मिनट sorting में वो क्या करो try to bubble sort we know kind of. Okay,
Bubble sort I
or else all you
hmm.
tell once.
Bubble
What?
sort I
Uh,
uh, will compare each element with the next like from first point to from first to the next element से लेके last element तक we'll keep comparing and we'll keep shifting those places till the it will move till last I think uh, something like that I remember bubble sort.
yeah, bubble sort may. I think what we'll do is
This
wait.
first element is there, some array is there. Now this element, if it is largest, means it will what it will do, it will compare with this, it will shift here. Then it will this will compare with what is say this element what it came here.
No,
It will
wait. Why
compare
don't
with
we'll just do off and square, no? Like
yes, we'll do a square.
best case is also off and square. No,
Yeah, yeah.
best case, average case, worst case, all are off and square.
All are off in square.
Yeah,
Yes.
so this is a dumb sorting thing.
Yeah.
So what is selection sort then?
Selection short में what we were doing is we were shifting for each index.
Yeah,
Now A से B, then A से C, A से D, A से E, A to F, A to G, A to H. Like that we were comparing and
yeah,
we were just shifting. But
yeah,
here selection में what we'll do is we'll take one minimum element. We'll compare in all from B to E. We are comparing with A. We'll compare till last and
yeah,
then whichever was minimum, we'll shift that shift with that element.
yeah.
That element with the minimum index will be shifted to the first index and the first index element will be shifted to that other index element.
Yeah, so like that we'll do until n. This is also I
Hmm.
think O of n square only. But the thing
Worst
is,
case is O of n square. I
uh,
think best is O of n log n. I think best one. Average is also I think n square. I think
okay.
because we are reducing that what you say
Swaps, we are
uh,
reducing the number of
swaps.
swaps. But we are
Hmm.
all that, but Imentaru, we are still the kind of comparisons we do is O of n square
Yeah. Worst में and average I think both are n square.
only. Okay.
Hmm.
What is insertion sort?
Now insertion, what we were doing is we were comparing and again shifting it to the first place. No
Mm.
insertion, what it will do, it will directly take that element and it will put in that index. like first index element, we were comparing it with all from B to last element,
Yeah,
B
yeah,
index to
yeah,
last.
yeah,
So that element, whatever is smaller than what you say, smaller than that index, we were swapping it. No,
yeah,
instead of swapping, we were just inserting it in first. I think not inserting first. I think we will inserting it behind. I think between those two, and this rest all elements are getting pushed to the next index. The afterwards, I think.
yeah. Insertion sorter. Basically, we think left side is all sorted. I guess something like
Hmm.
that. Left side is all sorted. Then what is
Hmm.
say the right wall element code? What we'll do is until
We'll,
the numbers are bigger, we'll push them.
yeah,
Yeah,
and we'll insert the element which is
yeah.
smaller
And
than.
once we hit the what is a limit, then we'll insert it at that position.
Hmm. Yeah,
Yeah, that's much I got. Yeah, I remembered. Okay, so the difference between selection sort and insertion sort is selection sort में first you are doing the
we
comparison
are
between.
swapping selection. We are swapping insertion. Mein, we are inserting it in the between those elements.
Yeah, yeah, okay. Got
That
off.
is the difference.
Then merge
Hmm.
sort.
Merge sort, we'll divide it into number of arrays till we get each array with only one element, and then
अरे
then we
merge
will
sort का एक बार
merge.
देखना पड़ेगा रे. I mean I forgot the code. Leave off. Okay, quick sort.
Quicksort, I think that pivot element will be there. We'll take one pivot element, same like merge sort. We'll divide it into some arrays, and then we'll take one pivot element. We'll compare it from left and right. We'll keep checking if left and right are something, what to say, less than or greater than. Based on that, we will sort in those two arrays. I think something like that.
Yeah, I think we'll take a pivot. Then what will we do is what I say we'll take. I think it's 2 pointer something we'll do no.
Yeah, that's
Aiko,
what two pointer will do. We'll
Aiko you'll increase until they are less than something. G.
Yeah, then if it is greater means we'll swap the pivot, I think. Swap direct the pivot element with the greater element, something like that it is there.
This thing is, once you see them, once you see quick sort ka what quick sort and merge sort will see codes. That's it. That's it. Sorting done. Other than that, all other sorts are fucking sorts.
Hmm.
Um.
See, pivot is there. We divided it into two.
Mm.
Hmm. Then again we took one pivot. Year two we took pivot.
No, we leave
Uh,
off. We got a quick sort. This thing we want that that two to three loops will be there. But that loops we want leave off this. Yeah, cross go down. Yeah, what are we doing? If array of j less than pivot I plus equal to 1.
hmm. Then we are swapping that elements if it is what you say less than the pivot. See, it's written traverse from array of low till high, move all smaller. Elements to the left side will be on smaller, and elements from low to high are smaller after every iteration.
Wait a minute, go down, go down. Array of quick sort of array of low comma pi minus 1. Yeah, partition will give the index. How many elements
Mm,
are lower, how many elements are higher. It will give
higher.
the yeah. So then we'll do
Mm,
from array of low to pi minus 1 and then we'll do from array of pi 1 plus 1 to high. That much we know. Okay.
mm,
So we'll where show the what you say partition wala code. Partition wala code में array of low to high. Pivot is equal to array of high. I is equal to low minus 1. Low minus 1. Why low minus 1?
because uh, index of smaller elements and indicates the right position. Okay, yeah. Uh, okay, this is reverse. No, we are going. I think from what to say. I
I
What
think
I
it's not
remember,
the code, Ray. I think there's a better code or something. Wait a minute, let me find it.
because what I remember was we used to do low plus one, and pivot will be I think a of low. I think something like that. It was there. I think I don't remember.
Yeah,
Array
yeah,
of low we will take pivot, and I will be low plus one. It will go till high. Something like that. It was there.
yeah.
They're
Let me
just
see.
doing it in reverse order. I think.
Let me see. Let me see. Let me see. Is he merge sort by then? Let me see something about quick sort.
Got huh?
Yeah, kind of. Okay, నిమిషం. I need a, what is it, that code, Ray? That code I remember. One code I remember. That code will be there somewhere.
I think wait classroom we have no classroom. I think we'll.
Are everybody showing this new algorithm? Okay, this is new algorithm I never saw.
Mm,
Okay, this new algorithm is also easy only. I think, see this, what is a this new algorithm क्या हो रहा है इधर I is equal to low minus 1. अरे यार ये इस तरह के- okay, there are multiple ways. This actually is easier, I think. Right?
easier, huh?
This is easier. That thing we remember, no? It had three steps. I remember.
Hmm.
So whatever we did now, it used to be like we used to take a left side pointer, we used to take a right side
Yeah.
pointer, and then we
Hmm.
used to do until what is a left side pointer we will increase until we get less one. Right side pointer will decrease until we get the greater one. Then we'll swap
Hmm.
those two elements.
And if it crosses pivot, I think,
Yeah, if
then
call
we'll
then
swap.
we'll swap with pivot. And that,
mm,
yeah, that used to be a very shitty algorithm.
mm,
This is easier algorithm. So basically what is happening is we are just ensuring that all the elements, lesser elements are to the left. So
left.
we are starting with I is equal to -1, and anyways we'll do I plus 1 bulk. We are starting with I is equal to low -1, and even if it is -1, nothing will happen. So basically what we are doing is, for j in range of low to high, we are trying to do that.
हर्ष कल 9 बजे तक तू रेडी होके कंप्यूटर के पास आके बैठ जाना
I think now I have to
Mm,
learn video editing also. Okay,
चालीस
cool.
वालीस मिनट का बोला
What?
uh,
Where are we? So yeah, quicksort में. So this is an easier algorithm, wherein what we are
mm,
trying to do is that if array of j less than p but only, we are just increasing I.
mm,
So directly we'll already always what we are doing is we are swapping what is a j with pivot element.
mm,
So anyways, whatever, no, but what will happen is swap of array of I comma j. What is j, man?
mm. J is this one from low to GH. What is GH? GH, I think high it should be here. What is GH, Ray?
Yeah, that is, no, GH is high. What is GH? Huh? What is GH?
GH is not declared anywhere.
No, it's okay. Leave off. Go to W3 schools one. I think if you go in W3 schools one, it is easy only. It's fine. We can see quick sort sometime. I guess we are not the best guys to do anything. Leave off. Leave off. Go to product notes. Yeah, this is easier. See, this is what I was telling. So what we are doing is we are going from low to high. If array of j less than equal to pivot, what we are doing is increasing I, and then we are swapping I and j.
Okay. Mm,
So if we are not, so how we have to remember this is I will increase only if array of j less than equal to pivot.
mm,
Else I will remain at some other place only. Okay.
yeah.
Then once we get the lesser element, which means that that element already should be towards the right side. So
Mm,
that element will swap off.
mm,
That will do from low to high.
mm.
Okay, and in the best case scenario, what will happen is this will perform only n log n times
Yes.
somehow. Okay,
Yes.
don't think, but this is an easier code to remember.
Mm,
Okay, leave off. Leave quicksort, leave merge sort also. Merge sort also, it's irritating shit. Leave off. Go to product notes. Yeah,
next.
go down. Insertion. This all we discussed off. We discussed off. Count
ठंड
short is nothing. Count short is what?
लग रही है ठंड लग रही है
What is count short, man?
Count sort is that array. Matt will take one array. In that array, will fill it with what is a frequencies, and based on those frequencies,
Yeah, okay.
we'll
We'll
sort it.
swap it. Count short is nothing but the indexing. Leave off.
Mm,
Okay, next
mm,
go.
mm.
Then we have started with
Two
the
pointer.
fucking two pointer. Okay, what is this?
But sort using two pointer.
Okay,
Next,
leave
mm,
off.
over. What is this? That sort zeros and ones.
So yeah, what
Sort zeros and ones using two pointers.
what we should do?
Just sort this array
Okay,
in zeros and ones.
okay.
That's it.
So what
Using
are we
two
doing?
pointers.
What are we
Same
doing?
thing. We'll take two pointers. One from both from start. I think.
Uh,
Uh, we, we'll go.
increase the left until we reach a one.
Okay, we are starting from left and right. Left and right. We are starting.
Uh,
Then we'll keep increasing and decreasing.
uh,
Whenever the pointer will uh, uh, encounter any zero,
uh.
then it will stop. And whenever the right pointer
No,
will
whenever the
encounter,
left pointer will encounter one, it will stop. I guess no, zero should be
ah,
left
yeah,
side.
yeah, 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 If it
So
encounters 1, it will stop, and if it this one right one encounters 0, it will stop.
uh,
Both will get swapped here. It will
yeah,
keep going on like that.
yeah,
It
until
will be
yeah,
done in
it will
O
oh,
often.
often. So basically, two pointers are always often. We should remember this because
Hmm.
basically दो pointer मिलके often में कर देंगे.
Hmm.
Yeah. Thanks.
Next, math sort again, same thing. Then master's theorem. Hmm. Same for this.
Hmm. Master theorem leave off. Next,
Hmm. Next, sum of pairs.
sum of pairs.
This one, a of I plus a of j equal to k.
So this is what for sorted, no?
No, this will not be sorted.
This will
See,
not. This will not be sorted means it will take off n square time.
no, we'll use uh, we'll sort it and do no, so it will take n log n. No, we'll sort it here.
Yeah, first we'll sort.
We'll sort and then we'll do. So it will take n log n time.
So first sorting के लिए n log n. And
Then
then
again for doing this procedure, two pointer procedure, it will take n again.
yeah.
So it will overall be n log n.
What will increase I whenever what you say the sum is less. Will decrease j whenever the sum is more. That only, na?
See, a of low plus a of I, if it's greater than k means will decrease,
High.
and if
Else
and
will increase. What?
else low plus plus, and
If
if it is equal means will return true. That's it.
else, yeah, that's it. Leave off.
Then what is it? Binary search recursion.
Okay.
Mm, Same binary search we'll use, but we'll use it in form of recursion, where
Okay.
we'll call the function again and again.
Okay.
Mm, mm, what is this one? For every query, print the frequency of query.
What is this?
So will be given, I think this array will be given. So for each query, whatever we enter, we should print the value of that frequency that is occurring in that array. We can use linear search. We can use binary search also. We can use hashing also. And we can use count sort also. Or else sort it and use binary search and store all the occurrences of queries. That also we
So
can.
linear search means for every query we need to search for n times n into q.
It will be n into q.
Yeah,
Binary search it will be log n log n
plus
uh,
login
plus log n plus q.
plus login plus q. Why we need to find its level left side boundary and we need to find its right side boundary.
So q times will do no for each query it will do no.
No, no,
So
binary. No, binary search means it should be sorted A. Okay. Once it is sorted, all fours will be at one place only.
so that's what n plus q I'm telling no.
No, no, we have to do n log n plus. Then
Ah
we
yeah,
can
n log n plus q.
no plus n plus q nahi plus n plus nahi. You have to do something with floor and seal. Nahi. You have to find floor. You have to find seal. Then we can directly send off. So n log n plus log n I guess. Remember,
Mm,
remember a seal you have to find. You have to find low floor. So you'll get what is a left side frequency ka boundary, right side frequency ka boundary. Then if you do j minus I plus 1, you will know the frequency.
mm,
You remember,
yes, yes.
yeah, something like that. I think in login plus login plus login something we have to do.
मतलब बोले ना टेंशन
Hashing,
लेके मत सो
hashing is just hashing.
शांति से
Just to keep it in what hash map.
हाँ
Uh,
घर को
Count sort is counting count array. If you use count array, it's
counter.
count sort array.
ठीक है
Then sort
Mm,
it and use a binary search
बहुत ही
to
ठीक
sort
करता
all the
हूँ
occurrences of
काम होने का भी
queries
yeah
for
this
all the
whatever it is.
लेकिन
Leave
शरीर
off.
same.
मुझे पता तो चलेगा ना
Mm,
अब क्या तो देखा
same what you told.
Floor and Sheila.
मैं ट्राई करूंगी मैं
Bin
लैपटॉप पे देखूंगी मैं ट्राई करूंगी कि
What is this?
calculate first and last occurrence of index using
वही
one
मैनेज
two
करूंगी
binary
मैं
searches.
फिर भी
Okay, leave
ज्यादा
off.
कुछ नहीं रहेगा जी
What is
मेल ही
this?
करना रहेगा
Q
मेरे
into
को
yeah, this only I was telling. This only you are
लेकिन
telling. You tell.
तो
One
कुछ
first
हो
one is linear.
हाँ
Hmm.
ये
Second one
पापा ना
is q plus and what is this?
नहीं नहीं
Hash.
गुड
Hash.
नाइट हर्ष गुड नाइट
What
बेटा
is
Hmm.
array then?
कुछ काम
R is I think storage of hash ray.
What
बेटा जल्दी सो
what is
जाओ
r? What does
बेटा
r signify then?
Storage ray R is I think storage in the hash hash
Whatever.
map.
I think q plus n. Okay, q plus n is so n is doing for all the numbers, and then q is number of queries. Leave off. Then n
Hmm.
log n is sort. Then q for every query we have to log, and we have to bind what q into log n plus n. Now what is that? This only I think we got irritated. Log.
Hmm.
What is this?
Login will first find in binary search.
Hmm.
Then uh, after finding the first occurrence, we'll go till the last one. So in worst case, it will be till last no.
Hmm.
I think n for that.
Okay, then we'll sort and we'll do for every binary search.
Every binary search one for finding the first occurrence, then for second occurrence, same.
Okay, that is the floor and seal one.
Hmm.
N log n plus q into log n plus log n. That is for floor and seal.
Hmm.
Okay, the what is the fifth one then? N log n is sort plus n is compare sum.
N is I think that count sort. I think no, not count. Uh, what n? I also don't remember. N
That
plus
only we saw the fifth one and sixth one and we were fucked off. Like what is
Q
happening?
plus Q
Q
log
log n
Q
plus
plus
q plus q
Q
log
plus
q plus.
Q.
What is that happening?
Leave off. Don't waste time.
Okay, leave off then.
Then again, what?
We'll see. Wait, I think half an hour should be coming. But yeah, half an hour is coming near. What is the next one?
Next one is hashing.
Yeah, hashing is a big topic, no? What is that? Next is hashing and
Wait, this all we can skip. I think this is all theory.
okay,
Hmm.
okay.
This
Like
is
this thing, and no, this thing we can do like hashing के लिए like थोड़ा तो भी कुछ समझ में आना चाहिए ना what makes a good hash function and all we have to remember. Okay, this we have to.
what Ray? All this is theory, Ray. What you'll do with all this?
Okay,
Can directly start with strings. No,
I guess what we did now, we did binary search,
we did binary search. We did recursion.
we did sorting.
We sorting. We did yes.
Only these three, huh? What else we did?
No, nothing
Sorting,
else
sorting.
there.
I think we took. It took time. It takes time, I guess. Quick sort we have to remember. Pakka. That shit
Hmm.
is big. Merge sort is just explain the divide and conquer. And
Hmm.
hope the interviewer does not ask you about that thing.
Hmm.
Then what else was there? Binary search. Binary search, it is login, right? Just
Hmm.
uske baad. I think binary search will come in high product nodes. This is one thing that we have to remember. Then we also discussed two pointers.
Hmm.
To go from left to go from right, this will take O of n time. That's one important thing that we discussed.
Hmm.
D off then. Until the here it's fine, then we'll do hashing. Wait, I'll stop.
Hashing, nothing is there.